Hello and welcome back to another VHDL tutorial. In this tutorial, we are going to see or we are going to write code for the 4x1 multiplexer. A multiplexer, the definition is given here. You can read it out. And the multiplexer has some select lines through which we select the output based on the select lines. This is how a 4x1 multiplexer looks like. It has two select lines and four inputs I0 to I3. And this is the least significant bit, this is the most significant bit, and this is the output. The output Y is determined by the select lines S0 and S1. So here is the truth table of this 4x1 multiplexer. If the select lines both are 0 0, if this is 0 0, then the first input, that is I0, is output. Likewise, if we have select line of 0 1 1 0 and 1 1, the output is based on the select lines. This is the boolean expression for function for the output Y, but we are not going to design our 4x1 multiplexer with the with this boolean function. We'll be using a case where we will be having, if we have this select line 0 0, then the output will be I0. If we have 0 1 of select line, then we will fetch the output of 1 I1. Likewise, if we have 1 1 select line, then the output will be I3. Let's start. Create a new project and name it mux. Next, create a source file. Okay. Next, next, selecting device here. Oh, finish. Okay. Now, as here we have four inputs of a single bit. These are the single bit inputs. These may be 1 or 0. So we will have 4 A, B, C, D as inputs, and we will be having a select line here, which consists of 2 bits, and we will be have to fetch the 2 bits simultaneously. So instead of using separately S0 and S1, we will have an select line vector which will be of 2 bits, and we'll select this check mark, this bus, and it will have 2 bits. And next we will have our output Y, which is of direction out, and it is also a single bit. Okay, so our source file is ready. In the simulation sources sim1 here. Okay, here we have our four input ports A, B, C, D, our S, our select line vector, and our output. After begin, let's start. Write process, and we are going to give S here. We are going to begin this process, we are going to end the process. After, we'll start our case is, and we will end case. And then we'll have, when we have select line 0 0, as it is the vector which has 2 bits. If these 2 bits are 0 0, then our Y will correspond to A. As A, we have kept A as the most least significant bit. Likewise, if we have 0 1, then our Y will be B. We have 1 0, Y will be C. When 1 1, it will be D. And we have to mention this others case at the end, and for that we will show don't care. Okay, this is our source case, source design. Why it is showing string literally, it should be single quotes. Okay, what this not this, this is this. Here we have written that if our this select line vector is 0 0, our output will be I0, that is the most least significant bit. We have kept A as least significant bit, and if we have 0 1 of select line, then we will be fetching the output of B, and if we have both 1 1, then we will fetching the most significant output, that is input, that is I3, or we have kept here it is D. For all other cases that are not in these four cases, like if we have don't care 0, don't care 1, or don't care, we will be fetching output of Y equal to don't care. So let us save this, save and run synthesis. It is running here. Till then we will copy these ports here. We can use some if else statement also here, but this one is very short. Okay, cancel. Click on this sim1, this plus sign, create a new add or create a new source, simulation sources, create a file, name it whatever you like. Okay, finish. Okay, yes. Here, after this architecture behavioral of mux tb is component mux. Okay, after that we have to initialize the test bench signals, as test bench has its own inputs. So we will write atb, these are of std logic type, uh, signal s, and this is of type vector, vector of 2 bits. After that we have y, this is of std logic. There is no need to initialize these, as some initialize these signal like this. There is no need to do this, and keep in mind that you name the two files differently as mux and muxdb, so that the components here are of different names. Otherwise it will create error while you run the simulations. Okay, after this we have to port the maps. We have the we have to port map. Further we have to write this dut, and we will write the name of the component for and port map. After that we will write these ports here. We can do uh, here also like this. If we have, it is like a equal to atb, b equal to, we are assigning these ports ctb, dtb. Like you can also do like this, but I prefer to do by copying all these. Okay, after that we write some, we write some test case here, and we'll end the process. First, we will initialize all these signals that are these I0, I1, I2, and I3. Here we have A, B, and C. We will write ATB. We'll keep it 1. BTB. We'll keep it 0. Uh, we'll, we'll keep it 0. We'll keep it 1. So we have initialized these signals that are these 4 inputs. After that, we'll we'll fetch these select lines. We write first our is STB. It is STB. We write it. First, we will fetch 00. Then we will wait for 100 nanoseconds. Then we'll copy it. We'll paste it, and here 10, then 01, then 11. So we have no error in our code. We run simulations after saving the code. Okay, so let's maximize it. Fit to screen. You can click on this button, fit to screen. Here we have. So let us expand this. Here first our select line is 10. If our select line it is 01, select line is 01. That is select line is 01, then we should have second output, second B as output, that is 0. It is correct. No, here for the first case we have select line of 00. At 0, A is the least significant bit input, then our output should be 1. It is 1. For the second case, after 100 nanoseconds, after second case, our select line is 101. Our select line is 01, so our output should be 0. Here it is 0. After third, our select line is 10. Our output should be C, and it is 0 again. For last third case, our select line is 11. Our output should be this third last input, that is D1, and our output is 1. So our code and truth table is verified.